Okay, in this lecture we will discuss about the rotating magnetic field. What is rotating magnetic field and how we will be getting it. So mathematically we will prove how magnetic field will be rotating and under which conditions it will rotate. So for rotating magnetic field we need to have three identical coils which are displaced by 120 degrees apart from each other in space. So in space there should be 120-degree separation should be there for three identical coils. That means they should be balanced. Identical coils means they should be balanced. Fine. And if we energize these three coils from a three balanced three-phase supply, like from a balanced three-phase supply, then we will be getting rotating magnetic field. So these are the conditions to be satisfied for getting rotating magnetic field with respect to three coils. Fine. So here each coil will be producing an alternating flux along with its own axis. So when we energize a coil from an AC source, what happens? There will be alternating flux produced along its own axis. So here the three coils are displaced from each other by 120 degrees. Then we will see how the resultant flux will be there by considering all these three coils. Right. So now we will first consider the fluxes which are like pi 1, pi 2, pi 3. We all know that the flux will be sinusoidal. So we are giving AC sources, three-phase voltages. Then they will be giving three-phase currents which are separated by 120 degrees in balanced supply system. Okay, then pi 1 will be pi m sin omega t, pi 2 will be pi m sin omega t minus 120 degrees, and pi 3 will be pi m sin omega t plus 120 degrees. Right, these are the instantaneous fluxes. So because they are in terms of time, they are time domain functions. That's why they are instantaneous fluxes. Right. Okay, now we have these three, right? So here what is pi m? Pi m is the maximum value of flux due to current in any phase. So the phasor diagram we can draw for these three cases, right? So these are the three coils which are separated by 120 degrees from each other, right? So this angle is 120 degrees and this angle is 120 degrees as well as this angle is 120 degrees. This is the phase angle displacement, like they are angle in space, that you need to understand. So as per this displacement, there will be flux along its own axis, right? Sinusoidal flux along its own axis. So then if R is the pi 1 first phase, it is pi 1, then pi 2 will be here, pi 3 will be here, right? They are having 120 degrees separation in space. So now in order to get the resultant flux with these three coils, what we will do, we will consider the resultant flux across the horizontal axis and across the vertical axis. Then the resultant of those vertical and horizontal axis will be giving the final net flux, right? So we will see how we are going to get that. So what is meant by horizontal axis flux? So the horizontal axis is here along with the pi 1, right? So in the direction of this horizontal axis, whatever be the flux component due to pi 3, pi 2 as well as pi 1, and their sum will be total horizontal flux. So if you write the resultant horizontal component of flux, so due to pi 1, the horizontal axis component of flux will be exactly equal to pi 1 because it is oriented or aligned in the direction of horizontal axis. So pi h will be equal to pi 1. Then what about due to pi 2? Due to pi 2, if you see here towards the horizontal side, we have here 60 degrees angle, right? We have 60 degrees angle here, and due to the 60 degrees angle towards the horizontal side, we will be getting pi 2 cos 60, and this is towards the negative side of the horizontal axis. That's why it is minus pi 2 cos 60. So similarly, what about pi 3? So due to pi 3 also we have 60 degrees towards the horizontal axis here. Then again this is pi 3 cos 60 degrees. So that is also negative. So the resultant of these three, or the sum of these three, will be the resultant flux on the horizontal axis. Right? This is pi 1 minus of pi 2 plus pi 3 into cos 60. Fine. So that will be coming like this. Then if you substitute pi 1 equals to pi m sin omega t, pi 2 equals to pi m sin omega t minus 120, pi 3 equals to pi m sin omega t plus 120, we will be getting one single value which is nothing but this. So with the simplification you can get this. You all can try this. Okay. Then what about vertical component of flux? Similarly, if you see vertical component of these three fluxes, what is the vertical component of pi 1? It is pi 1 cos 90 degrees. And what is cos 90? Cos 90 is 0. That's why pi 1 component will not be there. Fine. Then what about pi 2? With respect to pi 2, vertical component is towards the downside of the vertical axis. Then it is minus pi 2 cos 30, because this is 30 degrees. Similarly, pi 3 is plus pi 3 cos 30. So that's how you need to understand it and write the equation. Then the resultant vertical axis flux component will be coming like this. Now, if you write or draw the phasors of horizontal axis component, vertical axis component, then the resultant will be pi r. As per Pythagoras theorem, you will be getting square root of pi h square plus pi v square. So this will be giving a value of 3 by 2 into pi m. So this is what 1.5 into pi m. That means it is a fixed value, right? So it is a fixed value. The resultant flux magnitude is fixed, right? So now what about the angle? That is fine. Angle will be equal to pi v by pi h, that is tan inverse of pi v by pi h will be the theta of pi r. So what is that? That value is 90 minus omega t. This is very important here. That means this angle is not fixed with respect to time. So in generally we have seen the phasors while drawing phasor diagram of many circuits, the angle is fixed number. But here if you see, it is not fixed number, it is varying with respect to time. That is 90 minus omega t. So that is what you got here. So from this what you can understand, while you vary the time, that is omega t, the theta will be varying. That means the pi r resultant flux will be continuously displacing, or it is varying its position with respect to time. So how it is varying? If suppose if you consider omega t equals to 0 degrees, theta will be 90 degrees. Then at omega t equals to 90, theta will be 0. At omega t equals to 180, theta will be minus 90. So like this, its position is changing, the position of the resultant flux. So that means what you can understand here, the resultant flux rotates in space in the clockwise direction with an angular velocity of omega radians per second, right? Because this is omega, which is radians per second. Therefore, for a machine of p poles, we can say that omega will be 2 pi f, we all know that, and f is equal to p ns by 120. So this is with the relationship between mechanical angle and electrical angle, you can get this, right? So finally the conclusions are like the three-phase currents of a balanced three-phase supply system produces a resultant flux of constant magnitude in the motor, and which is equal to 1.5 pi m. And this resultant flux is rotating in nature, and it rotates at an angular velocity same as that of supply currents. Fine, because that is omega. And the direction of rotation of resultant flux depends upon the phase sequence of supply system. Right? What is phase sequence here? Phase sequence is RYB, because we are considering R as pi 1, Y as pi 2, and B as pi 3, which are separated by 120 degrees, and Y is having minus 120 degrees, B is having plus 120 degrees displacement from R. That's why it is a phase sequence of RYB. Fine, this is what the rotational magnetic field and how it will be produced. That's it. Thank you.